Hello, I'm Charlie Stripp, and I'm the current president of the Mathematical Association. And in my presidency, I'm doing a few kind of video interviews with various prominent people in maths education. And the person I'm talking to today is Tom Button. The themes that I'm addressing during my presidency are around attitudes towards maths and maths education, around the chronic shortage of secondary maths teachers, and around embedding technology into the teaching and learning of maths. And the real focus today, because I've got Tom Button with me, is to think about embedding technology in the teaching and learning of maths. So Tom is the MEI's maths technology specialist, and what that means is that he's not concerned with using technology to administer your classes or anything like that. What he's concerned with is how technology is actually used to enhance students' learning in maths in the classroom, and that's a focus that we're going to talk about. Another thing we're going to talk about is around data science as well, because again, Tom's been doing some pioneering work in data science in the curriculum. So Tom, let's start off by talking about maths teaching in the classroom and how technology can really enhance that, and I suppose where we are with that at the moment in our teaching and learning in this country, and how things are progressing, where we're trying to get to. So Tom, over to you.
Yeah, so I think, one of the things that I often say, I've been working with teachers for many years on technology in the maths classroom and thinking about how can you embed technology to support teaching and learning. And one of the key things that I often start with teachers and talk to them is the idea of I'd like technology to be judged like any other teaching strategy. So if teachers start thinking about something like, should I use this style of questioning in my lesson? Should I use this particular resource in my lesson? Essentially, there's almost only one criterion that teachers use for that, which is, will my students understand the maths better if I use this?
Yeah.
And I feel like technology should be judged with the same as any other teaching strategy. And so that's kind of the key thing that just before we even start, just to say, I don't think technology is great because it looks fancy. I don't think technology is great because it's somehow more engaging because it's on a screen than on a piece of paper. I think there are certain mathematical tools that we can use that mean students understand mathematics better. They have a better conceptual understanding. They have a better ability to be able to repeat the mathematics they've learned. And so that's kind of where we started. So what is it about a particular mathematical tool that means students understand the maths better? I don't know if that's something that you've kind of experienced.
I think that's a really good way of thinking about it, because I think one of the problems perhaps with technology in maths teaching has been it being viewed as some kind of separate add-on that you kind of, I can bring some technology in here, almost as if you're bringing the technology in because you want to bring technology in, not because what you're trying to do is to just teach the maths as effectively as you possibly can. And there are certainly significant bits of the curriculum in maths which can be really, the teaching and learning of them can really be enhanced by the use of technology. And that I think is a really key point. It's something that just it should just be thought of as part of teaching and not something that you're
Absolutely.
adding in. So yeah, I think that's a. I mean, I know Tom, you've been working on. So I remember when I first came across you was probably back in the 1990s when you were a classroom teacher at that time, but
Yeah,
making
yeah, yeah.
really creative use of technology. And then you've now been working in supporting teachers to use technology in teaching for 20 years now. So I know this is something that you've got a huge amount of experience on over the years. I think we're absolutely agreed about the value of using technology in the classroom. In fact, I know in a minute you're probably going to show us a few
Yeah,
things,
yeah, yeah.
but another thing that we might talk about is the kind of frustration of why we know this. There's general acceptance of the value of technology in teaching and learning mathematics, and yet the adoption of that technology in the classroom in teaching practices isn't nearly as widespread as we feel it ought to be, and that's been a frustration. But let's start off by thinking
Should we do the
about,
why?
yeah, go
Should we
on,
do the why bit? We've not
yeah,
really kind of
do the
done
why, do the why, yeah, do the why.
yeah, yeah. So if we are going to judge it like kind of, do students understand the maths better? I feel like technology, or certainly mathematical tools, and I'll put one up on the screen in a second, really give us two big things, which are, one of them is this connection between different representations. Certainly, algebraic and graphical is a big one within the secondary curriculum. But I would add in numerical about that, and I'll mention that in a second. And then the other one is this ability to change something and observe the effect of, if I change something, how does something happen? How do these help students give these concrete examples, but lots of them as a stepping stone to generalization. So they're kind of the two big things for me, the multiple representations, and then this idea of how easy it is to change something. And I'm doing all that by waving my hands around when I'm going to be far better talking about something directly on a screen.
Right.
So if we just
Okay.
go
Let's get something on the screen. Excellent. So this is Desmos, right? Okay.
yeah,
Um.
so just there are a number of tools that we can that you can use in the classroom. Autograph, Desmos, GeoGebra, graphical calculators are probably the main ones that I think maths teachers are familiar with in this country. I'm using Desmos at the moment. I could have used any of them. Desmos seems to be very popular. I think the look and feel of it appeals to a lot of teachers, and the easy use appeals to a lot of teachers. But in terms of describing what I've got in the screen in front of me there, if I was going to be teaching equations of straight lines, which is a topic that obviously permeates a lot of the Key Stage 3, 4 A-level curriculum, just this concept of a straight line. We have this y equals mx plus c. We have this notion of a gradient and a y-intercept. But that, if I drew one y equals mx plus c on the board, that's pretty static. With a slider, I can now start changing that and start asking students to think about, well, what's changing? What's the same? What's different? If I change this M, I can even go slightly better than that, and I can press play. It's a bit fast, that one, isn't it? Should we slow it down a bit? And start thinking about, okay, what happens as M changes here? What happens to the gradient of the line? Start thinking about some specific values. What does it mean to say M is 1? What's the same and what's different when M is 2? And this idea of changing something and thinking about what changes, what stays the same when I change something is such a powerful tool. And you can't really do that with pen and paper. We really need something dynamic, and we talk about the dynamic aspect of technology is so powerful in doing this. We've also got the multiple representation here that we can see the algebra, and we can see the graphical in the screen in there, and that's kind of the second of those. However, I did mention numerical. And when I did my master's, a lot of my research was in the use of technology and multiple representations, and I read a lot of papers around use of technology to show students multiple representations in maths. And there was a lot of stuff about the graphical and the algebraic. And I think there's a third one, which is the numerical. And I'm going to just quickly put that on the screen there. I've now got a table of the values as well. So now I've got 3 representations on the screen of this linear relationship of this is y equals 2x plus 1. I've got the algebra on the left, I've got the graph on the right, but I've also got this table. And now I can start asking students, where am I seeing the 2? Because here M is 2, my gradient is 2. Where am I seeing the 2 in the table?
Yeah.
What would happen? So then there's great ways you can use this dynamic stuff. So I've written a blog about this, about great questions to use with dynamic technology, where one of the great questions you can ask is, if I change something, how does it change? And actually have the thing animated, dynamic on the screen in front of students. So what changes? What stays the same when I change this thing? How does it change? Why is it changing like that? But you can flip that question on its head, and you can say to students, okay, if you think you understand how this is working, what's going to happen when I change M to 3? If I change M to 3, what we're going to see in the table, where are we going to see a 3 in the table? And I'm kind of hoping the students have spotted that these numbers jump by 2 every time X goes up by 1. So if I change M to 3, I can see that now that these numbers go up by 3 every time X goes up by 1. So I think they're the kind of 2 things, just to kind of draw on what I said there. The 2 things I was talking about were the idea of multiple representations, but really don't forget the numeric. I mean, that's probably how students first meet functions, isn't it? Or graphs, they meet it in terms of a table. and it's quite a concrete representation to hang on to. So we've got the multiple representations, but we've also got this dynamic aspect, which allows us to change things and think about why things are changing. What do we expect to observe? What do we observe? Why is that happening?
Yeah, what I really like about this is the idea of really connecting together ideas in maths. So you're connecting the graph to the algebra, and you're connecting the algebra to the table, and the graph to the
Mhm.
table, and all of those things and how they relate to one another. So I think
Mhm.
and the other thing I suppose is also the case that I when I was actually teaching, which is a long time ago now in the 90s when I was teaching, I tried to use a lot of technology. And actually, you had to be quite tech savvy to use technology then, because it was it wasn't nearly so user
Absolutely.
friendly as it is now. What we've got now is the kind of, I think that the barrier of being able to use a particular piece of software effectively and being, that barrier, I think it really has just about gone, because this software is now so straightforward to use.
Absolutely. And I think these tools are that much easier. They're really user friendly. So easy to get something like Desmos up on a screen, type in an equation, and you're way to go. Yeah. I mean, I think the other thing that's changed back from when uh, you and I were first teaching is pretty much every classroom's got a projector
Yeah.
or a large screen TV that's connected to the internet. And this is on a website. This isn't expensive software. This is freely available web-based software. I don't need to download anything. I don't need to pay for anything. I just type in Desmos and I'm away. And I think the fact that these tools are freely available. And the other thing is they're freely available on loads of different devices. So it makes it
Yeah.
really, it's freely available on a laptop, on a browser, but it's also freely available on a tablet or a phone or a Chromebook. And it just makes life so much easier when we know we have that.
Yeah. And in fact, Tommy, that's just prompting me to think about something that I know you feel very strongly about, is that this is what you've been showing here is great for how a teacher can demonstrate things to a class and have a conversation with the class about, what's going to change and how does this work and how these things link together. But I know something that you feel strongly about as well is the power of the technology in the hands of the student too. And I wonder if you could say a little bit about that.
Absolutely. I think um, I think many teachers will come into this, and I was the same myself. Is that when you start thinking about how can we use technology, using it yourself at the front of a class is the way in, and having something that we know we're comfortable with and straightforward is is probably where you want to start. But I know myself that I've learned so much from trying to get maths problems into technology. If I'm stuck, I get a maths problem in technology. If I've got an answer to something, I often go to technology and just check that my understanding's the same. Or if I've got a situation to explore and I'm not sure where to start, getting it into technology and having a look at the graph of it or having a look at the geometry of it is such a powerful place to start. And I know my understanding's developed because of that, and I presume students will as well. The other thing, I was working with a group of teachers yesterday, and we were talking about this, and we're talking about, what are the advantages of students using technology, and it came up very strongly from the teachers I was working with yesterday. Is they want their students to be independent learners, and I think most maths teachers have experienced the situation, of a student's done a question and they know they've got the answer wrong, and then they stop. They might be working with a textbook and it's got the answer in the back, and they get a different answer to the one in the back, or they just know something like the question's wrong. And the default, I think, for many students is stop, ask the teacher. Wouldn't we love it if our students got something wrong, saw they got something wrong, and then tried to sort this out? For example, here, say I'd set the students, give me an equation of a straight line, let's make up a value, that goes through 3 comma 4. So I want my straight line to go through 3 comma 4. How can I change my line so it goes through 3 comma 4? And one student says to you, oh, well, I could just change C to be 0. Well, the student tries that and it doesn't work. And my observation, these teachers said similar yesterday, is that students don't stop at that point in technology. They don't see C is not hasn't worked and stop and put the hand up and say, can you help me? It's wrong. What they tend to do is just carry on working until they've got an answer that does work. And there's an element of self-correcting in technology. I don't know if you can add any insight. It's something I've observed, and I don't feel I've quite got a reason why, but I've definitely seen it so many times that I think there's something. Maybe it's like the spell checker. If you're writing a Word document and you get the little red squiggly line, you don't go and get a dictionary or just stop writing your document. You just use your tool to correct it for you. And I think there's something about working in this. Maybe it's the impermanence, maybe it's the dynamic aspect of the environment that means students are kind of self-correcting, and I really like that in terms of encouraging independent learning.
I think you fit with a graph, you're getting kind of immediate visual feedback, aren't you? And you can and that I think we're part of
It's
the way
that
we
show
think
don't
is to
show
react to
don't
that.
tell
So
idea, isn't it?
yeah, yeah,
Like
I
sort
think
of
that's right.
cognitive dissonance. Show if somebody has an answer that isn't correct, just show them it's not correct and see if they can work out
Yeah,
why.
yeah. So again, I think brilliant that we've got really good ways of and easy ways of embedding technology for use by teachers in the classroom.
Hmm.
But a bit of I suppose, an issue about how we, in the long term, can make it so that students can use technology in the classroom as well. But what we want, I suppose, is for teachers, they can certainly access technology outside the classroom, and that's something that we should be encouraging them to do because, say, the software is free.
Yeah, I think it is a question worth thinking about. We know it's easy for a teacher in a classroom with a whiteboard or a big screen TV just to project it or just to kind of show it on the screen, but it's um, so much trickier to think about, well, what devices are going to enable students to do this in the classroom. And I think that's something that I don't want to make any big recommendations here, but it's something that really we need to be thinking of as the maths education community.
Yeah, I definitely agree with that. I think, I mean, we but very sort of, we haven't got huge amounts of time to do massive demonstrations of things, but you've illustrated very clearly how valuable and powerful and easy to use technology can be in the classroom in a way that's really going to help students learn mathematics more effectively. Um, why do you think? What are the reasons why it hasn't happened? Because I mean, I can remember I was using graphical calculators with my A-level classes in 1991.
Mhm.
So that's and thinking about certainly showing in a much more complicated way than as you're able to do it now, doing the kinds of things that you were just doing with GCSE classes as well. So what is it that has prevented it from becoming more widely embedded, you think, and what might the solutions be to how we can solve that? And that problem's been around for a very long time. And I know, Tom, that you've been involved in
Yeah.
reports from the Joint Maths Council about it and all those kinds of things. So perhaps you can talk about that a little bit, please.
Yeah, I mean, it's hard to not look to the assessment with this, and so certainly I don't think any of us would advocate teaching to the test.
Hmm.
However, being a realist, assessment drives classroom practice. I wish I lived in a world where that wasn't the case,
Yeah.
but I don't. So we've got to be realistic about this. We know assessment drives classroom practice. We can get if we demonstrate tools that are helpful in the learning, then many teachers will take them on. And I've seen some great things from teachers. When teachers see these things, many teachers do take them on. But we do know that assessment drives classroom practice. And I think to give an example of why, specifically with technology and maths, why we know this is the case, is scientific calculators are embedded into teaching and learning. Whether you like them or not, scientific calculators are just part of it. You go into a maths classroom, year 10, what are the chances you'll see students using scientific calculators? Unless there's a specific reason why not to. I mean, the teachers probably get quite cross if the students forget them. So that is a mathematical technology that is embedded into teaching and learning. Why is that the case? Well, it's on a relatively cheap, easily transportable device, and that device is allowed in the assessment.
Yeah.
And so that's this is personal opinion, but it feels like that's the big one for me. That we are driven by assessment, like it or not. Therefore, looking to the future, it would be a case of if we can make small inroads into this and we can get teachers using these fantastic tools, but to really kind of widespread change would require change to the assessment. And this is the case in other jurisdictions. Other countries do have graphing tools embedded into their assessment. And then the use of graphing tools is throughout all teaching and learning. And I think if teachers knew, don't really want to get into the mechanics of it because that feels like a side issue to me. We would know that if it was embedded into the assessment, we'd just see it in the classroom almost immediately.
Yeah, I think you're right about that. But I also think, though, I suppose that there's been some real breakthroughs in how easy these tools are to use, and so hopefully,
Totally, yeah.
people. I mean, even if we can't have use of technology in assessment in the near future, I think that the idea of how easy this technology is to use and how much it can clearly help students to learn more effectively, that there should be use of it should be really growing anyway because of the ease of use. And I do feel, I mean, I'm notoriously optimistic. Many people know that. And I kind of feel that the problem is with technology. I've been notoriously optimistic about it for 20 years, and my optimism hasn't proved accurate. But I do feel that the new technology, the things like that you're just demonstrating, because of its ease of use, it has become much. I think it's much more likely that there'll be more widespread take up by teachers. And I think that one of the things around that, I think, is also to do with CPD. And I know, Tom, you and I've got very similar views about this. So I'll let you talk about how we can enable teachers to actually empower teachers to use technology in their maths teaching. And can you talk about that a bit, please?
Yeah, so I think, this is something where, we recently produced, as you mentioned, the Joint Mathematical Council, JMC, put out a report on technology in maths education, which I was involved with writing, and we really looked at CPD and kind of what CPD would look like. I've been involved for many years in running professional development around technology, and I think specific courses on specific technologies have some value, but I don't think they're only ever going to appeal to enthusiasts. And what we tend to find when we run those type of courses is somebody who's really enthusiastic about using technology in the classroom will come on one of these courses, and then that will have an impact on their teaching. But for the vast majority of teachers, it's not the highest priority in their classroom. What we've tried to do with the Advanced Math Support Programme, or I think we've successfully have achieved, is really looking at how technology can be embedded throughout the practice, just in the way that you would want it in the maths classroom. We want technology embedded in math teachers' practice. This is realistic now. It's not like we said, when I started teaching, I had to hire out the projector if I wanted to project a graphing tool onto the screen. There was two projectors in the college, and I could hire one out. Now most teachers can do this quickly. So we just want it embedded. We want the teacher to be in the middle of an explanation of something and quickly put up a graph on the screen and move it around and then go back to the explanation of the concept that they're talking about. That's what it looks like when it's embedded in practice. And what we've advocated in the JMC report, what I think we've done through the Advanced Math Support Programme's professional development, is we've looked across our courses and technology is just embedded in them. If teachers come out on a study day on teaching statistics or teaching further maths, then during that they will see some use of technology in all the sessions. We'll talk about, okay, here's the topic. It might be hypothesis testing. It might be something about complex numbers. It might be something if we're doing A-level maths about calculus, differentiation. But we'll talk about the topic. How do you do it? And there will be some technology embedded in it. And I think that's the key. And I would put out a plea to anybody involved in professional development of teachers of thinking about not how you can have individual sessions on how do you use technology, or day courses so much on how you use technology. They're valuable, but really think about what is your professional development program looking like, and how is use of technology embedded into that program the way that we want it embedded into teachers and learning.
Yeah. I think that's yeah. I mean, I know that's what the AMSP does, and I think the point of it is that the point about it is that if you go to an AMSP session, it's not like now we're going to use some technology. It's just actually this is how you teach it, and this is the most effective way of teaching this topic is in this way, and there's no big deal made about it. It's just there, and that's what's kind of normal practice, if you like. So I'm sure you're right about that. I suppose something that I have heard people say about technology is where's the evidence that it improves students learning? You know, I mean, I don't use technology at all in my teaching of GCSE maths, and my students get really good grades. What would your comment be on that?
I mean, it feels like quite a reductive argument to, you know, do we reduce everything that we do in the classroom to the performance of our students in the exams, and should at all points in the classroom should we be only doing things that are going to maximize the students' GCSE results? And I think you know, I've definitely taught students myself who I've observed through use of these tools. You know, I've seen that they've had to develop their understanding. Their understanding has been more secure, and I certainly know from you know, we I think we've both encountered many people in university courses who know that where students have that deeper understanding through use of technology has allowed them to progress better. And you know, there's many courses, you know, if you look at university level, maybe not so much at the mathematics, but subjects where maths is used as a tool to support study in other areas. They're very technology based now, so I think it really does prepare students for the future. I think it's very, very difficult to do a rigorous scientific experiment on this. Whether I don't think it's feasible to take a whole year group and teach half of them for 2 years without any technology and half of them for 2 years with, and then look at the GCSE result. And even if the GCSE results were better with one group, I'm not sure that's valid scientifically to say it's proof anyway.
I think you're absolutely right about that. And I want to go back to the assessment point as well. That the assessment is you know, the assessment. If the assessment was designed in the knowledge that students had access to technology, and we're going to, you know, that we might be assessing, different things, and possibly assessing more useful things and things that are more relevant for young people's futures. So there's a kind of that's a. I mean, the world is changing dramatically. Technology is embedded in life now, and our curriculum and the way we assess things as well should reflect that, shouldn't it? So I think it's. I mean, but I feel sometimes that we and this all kind of, I suppose, I want to actually start talking about statistics and data a little bit, but thinking about statistics, one of the, I mean, you know, when I was first teaching, you know, what you do about statistics will be you'd have a table with 10 bits of data in, and you'd be asked to calculate various statistical measures and things and draw some conclusions based on you know, just and it really was the whole thinking about statistics and probability was around very kind of small data sets and very kind of instrumental thinking about things. And one of the things that we did with the current A level has a use of a large data set in it. We know that large data set often is kind of paid lip service to because the assessment of it doesn't really reflect how important that should be in teaching and learning. And so perhaps you could talk a little bit about data and statistics and probability teaching and how technology can impinge on that, or how it should impinge on that.
Well, I think just to kind of help make that connection between what we've just been talking about and move into data, I think it's worth reflecting on what we do in statistics. And to take your example around, you know, the mean of a list of 10 data items, I think, you know, why do we want something like a mean? We want something like a mean because it's a representative value when we can't kind of handle all of them. If there's 10 items in my data set, I don't really need a mean to understand them, because it's just about possible with 10. If we had even 7, it would definitely be possible to look at those data items. You give me the sales figures for a team of 7 people or a team of 10 people, I can look down that list and actually take in the whole list. If you give me sales figures for 1,000 people, I can't take that in. So it's kind of, so it is almost meaningless. I think the reason, though, why we might want to still teach some of these straightforward examples of is it helps me understand what a mean is if I've done a couple of these things. I've added numbers up and divided them. And so I've got this kind of thing we need to, Keith Devlin, if people are familiar with him, writes really well on this. The distinction between what mathematics are we learning because it helps us understand the underlying structure. And
Yeah.
what mathematics are we learning because we've got a process that's going to produce an output.
Yeah.
And we can outsource processing to technology, but we can't really outsource understanding to technology.
Yeah.
So I think there's a case for something like, and there's a strong narrative here to think about with something like the mean. I would want students to do a small number of examples with small data sets because I want to explain to them what a mean is. So
Yeah.
when they see a mean throughout the rest of their study, they understand what a mean is. Once they've done that, I'm not bothered about whether they can repeat that process, because actually for any data set of any size, I want to outsource that process into technology.
Yeah.
So I think that's, and maybe that applies back to some bits of pure maths as well. I want students to be able to multiply two-digit numbers together by hand.
Yeah.
It helps them understand place value. I don't want them to multiply two 5-digit numbers together by hand because that's just ridiculous.
Yeah.
But then I think we then start moving into the realm of statistics and data. This is even more so. We know many times we want to produce a chart, we want to produce some form of statistics. We want to produce a chart or some statistic or set of statistics about our data. And that processing is far better done by technology. We know outside of the classroom, nobody does this stuff by hand. We actually know with the size of data sets that are going to be realistic. And I think the large data set at A level came from a very good place. I think the implementation hasn't always been what people wanted it to be, but it came from this very good place of saying, here's an example of a deep data set in a real context where pen and paper methods aren't going to work because it's too big. People look at it. Anybody who works with data and thinks it knows about big data says, well, how on earth are you calling that large? Large in this context is probably worth stressing for people, means large enough that you don't want to do the calculations by hand. That was kind of the intention of it. And I think it came from a good place. And I think there's real value. I actually quite like that as data sets, and as somebody who's worked with a lot of data sets and tried to turn data sets into teaching and learning examples, I think they're actually well curated, all of them, from all the awarding organizations. They're good data sets. They're really useful in classroom context. But I think that's kind of where we are with those. And I think it's starting to look at how we might move the study of data and statistics into something that more matches the 21st century. And I know you kind of feel similar about that, don't you?
I do, yeah, certainly. I think, and in fact, the large data set again in A level, but it does again link back to the assessment problem. I think you're right that those large data sets that are supplied by the awarding bodies are excellent teaching and learning tools, but actually they don't often get used as teaching and learning tools because the assessment of those areas of the curriculum, in the way the exams work, is there aren't that many marks dependent on it, and students can get through and do what's required for the exam without having done the really sort of conceptually important teaching and learning that the large data set can facilitate, because that isn't really being assessed. So I think I agree. So I mean, I suppose we can sort of move through, Tom, now to something new, which I know you're really interested in, is how we can incorporate data science into the curriculum, into the maths curriculum, and into the curriculum more widely than that. And I know that's something you've been doing some quite exciting work on. And it relates. Technology is absolutely crucial to this.
Absolutely. So I think if I just kind of share a couple of examples of stuff we have been working on, and hopefully we'll be able to provide links to these alongside the videos on the website. So I think there's a narrative that's important to us in terms of thinking about how you work with data and what you do with data that we think the curriculum can essentially mirror this narrative. And so the current curriculum builds through to an endpoint, certainly of working with data in key stage, starts in key stage 2 through key stage 3, 4, through to the statistics in A-level maths and things like hypothesis testing. But the reality is, of the world that we're operating in now, is that artificial intelligence And ideas around machine learning are everywhere we look. Everything is being dominated by these tools now, these artificial intelligence tools that are built on machine learning. And we'd like the curriculum to reflect that and really think about they are based on data. And I think, when a student uses an AI tool, if a student uses something like ChatGPT, how aware are they that this is based on data, and the work they're doing with working with data lower down the school, the work on statistics is actually key to how these things work. If an automated tool is applied to them, if they, I don't know, if they apply for university or they apply for a loan and they get accepted or refused, how aware are they that that would be based on a machine learning tool that's based on lots of data? And I think that this is kind of so powerful. So our attempt to think about what is a suitable narrative that could go through the curriculum for students is, we've started producing resources on this, and these resources are available through the MEI website. So this kind of starts with the idea of what does it mean to start making decisions from data? If we start spotting patterns in data and thinking about how might we make decisions based on this data, and that's generally known in data science as exploratory data analysis. So here's an example from an activity we have. It's not that big a data set. It's a data set of 320 penguins, and people tend to like penguins. And this data set has got penguins of 3 different species. It's got measurements for those penguins and then a list of what the species are. We're using a tool here called CODAP, which is brilliant. It's been developed by some stats educators in the US, freely available again. I mean, I do think free web-based tools at the moment are what people want, and they're usable in the classroom. So it's called CODAP, C-O-D-A-P. This tool allows us, so you see here, I've got dot plots and box plots, and I've got the mean marked on here. So I think I can even, let's show the mean on there, so we can even see the mean of Adelaide, Chinstrap and Gentoo penguins. And you can immediately see, oh, well, Gentoo have got a bigger flipper length. I can change what's on the x-axis here. This is drag and drop. It's such a nice tool to use. I could change that to body mass, just drop that onto the axis, and it's changed. I could change it to bill length. And I immediately can start thinking about my data in a data science sort of way of, exploratory data analysis. What patterns can I see in there? What's in there? Well, I can start identifying what the difference might be with these birds. I could even, and I think this is novel to some people, I've used a scatter plot here, not for line of best fit, not to decide if there's any correlation, but actually to do a 2-dimensional version of what I've just did with my 1-dimensional dot plots. Can I take pairs of features, variables about these penguins, and think about, with the pair together, whether I'd be able to tell whether it was an Adelaide, Chinstrap or a Gentoo. And I think, and again, it's so quick to change this. If I want flipper length or bill depth on the vertical axis, I just drag that over and it changes again. And so what I love about this as a tool is it takes away that mechanical processing part of averages, of statistics, of charts, and really allows learners to focus on what is it we're trying to do here, what are the questions, how might we answer those without being worried about the mechanics of those processes, because they're not really the important thing. It also allows us to change our perspective to start looking at things like classification is a great tool. How might we answer questions with our data? How might we use our data to predict whether a penguin is of one type or another? And that's really at the heart of AI. And then where that goes, and again, we've got resources on our website. This is aimed more at sort of key stage 3, 4. We've got resources aimed more at A-level students that then goes into thinking about code. Now I know some code will be new to some teachers, but again, these tools, Python in these environments where you can import data, they're all freely available. This is the same data set imported into Python. And what I can do with this is, instead of me looking at the data by eye, I can hand that process over to a machine learning algorithm, and this machine learning algorithm has essentially done a flowchart. I mean, we're not going to talk about what all the numbers in this flowchart mean at the moment, but I think essentially, if you just look at the top lines of this flowchart, this has said, well, if the build depth is less than this, go this way, and if it's bigger, go that way. And then if the build length is less than this, go that way and this way. And at the end, you've got this thing. This one here was just trying to work out, is it a Gen 2 penguin? And I've now got a flowchart that tells me, is it a Gen 2 or not? But the key thing, I think, in terms of the narrative and what we'd want with the curriculum is this thing has been done by a machine learning algorithm. We essentially handed that processing over to a computer instead of just looking at this thing by eye and saying, oh, actually, I think they're here, they're there. You could imagine, you know, my data set here has got 320 records. There's one of the data sets we work with in one of our courses that's got 22 million records. So you just couldn't do that by eye. But you can hand that processing over to a computer, and machine learning is essentially that. It's a trial and improvement type method that's going to go through and decide where's the best place to put this boundary. So I get the fewest answers wrong. And that's how machine learning works. And modern AI tools are all based on machine learning. They're just tools that have been generated like this. They're a lot more complicated. You know, something like ChatGPT hasn't got 2 bits in its flowchart. It's got a trillion. But essentially, it's kind of doing something similar. I mean, all ChatGPT does is try to guess the most likely next word. It's just very, very good at it. But the other thing I like about this narrative is that I think this is so powerful, not just for students who maybe go on to do A-level maths or even A-level further maths, but I think this is something powerful for all learners, because it opens up a conversation around how is data used now in the world we live in the students. If they're going to go on to further study, further work, how is data actually used? Well, it's used to build models. If you're interested in what's happening with climate change, it's used to build models. If you're interested in finance or working for, you know, a commercial organization with online shops, you know, how is data used? It's used to kind of build these models. It might predict what products to advertise you. It might predict what the climate's going to be in years 10. It might predict what your sales might be next year. But also it be used to allow people, you know, say approve people for loans or not, or services. And I think there's there's an ethical element to this that I want students to understand this.
Yeah, I think what you're saying, Tom, is that there's both to be I suppose a citizen in our society, then it's empowering to understand how these things work.
Yeah.
Just from an ethical point of view, and from the point of view of you being I suppose an informed citizen, is also extremely useful, because it's likely to impinge on your employment, and being able to use tools like this and understand them and be able to just, I suppose, interact in a world where these tools are ubiquitous. You know, an understanding of them is essential. So it really is something that should be part of general education, because it is becoming so much embedded in society. And,
I think so, you know,
yeah.
If students are why are students learning about things like the mean lower down the school? Well, if they understand that they're learning it because the tools that run modern society, modern economy, are based on algorithms built on the analysis of data, and that's where this is going. And so, does my data represent the situation that it's going to be used for? When we see bias in these AIs, the reasons we see the bias in some of these tools is because the data that the tool was built with didn't represent where it was going to be applied.
Yeah, and so all of those things are just hugely important for society and for individuals' part in society, aren't they? So I know that we're thinking about how we might be able to embed data science in the curriculum and help to make sure that people have got a better understanding of all of this. I mean, could you say a little bit about the work that you've been doing there?
Yeah, so I think one thing that we've been doing is, you know, we've developed materials, and we're still developing materials, some of them which are very much tied to the curriculum. So how might you teach an actual curriculum topic as it is now, but thinking of it in more of a data science way. We've also created some short. We have some short courses at MEI. We have a freely available one. We have one we teach to students as well that they do on top of their A-level studies,
Yep.
so they can learn more about data science. I think what we're looking towards the future on and really thinking about, there was the recent Royal Society report about this, and that was very much looking at this, and they analysed our courses and came out very favourably.
So you're talking about the Mathematical Futures report, aren't you?
Yes,
from the Royal Society, yeah.
I am, yes. And then as part of the Mathematical Futures report, there was a separate detailed report on, I can't remember what it's called now, on existing data science programs, and we were mentioned in that, but it's heavily mentioned in the main Mathematical Futures report. And I think it's an open question for us, but one we'd like on the debate is, what does a future curriculum look like? Is this part of the maths curriculum? Is this part of the computing curriculum? Is it a subject in its own right? I think these are things, I think it needs to be in the curriculum. There needs to be a space for it.
Yeah.
How much of it is embedded into the existing maths or computing curriculum? How much of it is somehow a strand in its own right? I think is something we need to explore, and I'm not...
Yeah, I know that the Royal Society report, it talks about MDE, doesn't it? Maths and data education.
Yes.
And really, is it helpful that we do sort of separate these things so much? And I think looking into the future and how the curriculum develops. I mean, I think that the really important thing I'm excited about is that the work that you're doing in MEI. We're not kind of just talking about things hypothetically and sort of wondering what the future is going to be like. We're actually trying things out with real students in the classroom and understanding how things work and getting our hands dirty, if you like. And that's the way that we'll be able to make
think so, yeah,
useful progress in this.
But I believe in learning by doing in the maths classroom, and I believe in learning by doing with curriculum development. It's the same idea. You only experience these things. We've been teaching these courses online. I've been going into a local college and teaching students there. I think you only kind of really learn how these things will work when you try them with real students and real teachers and see how they respond to them.
Yeah, I thought you're absolutely right. I think it's such a, I mean, using technology to enhance students' learning in maths lessons. That's something that is, I suppose, within the current curriculum. That's something where we can improve what we're doing there. But the wider thing now also, and this wasn't the case when I started teaching, when I was trying to get people to use graphical calculators and things in the classroom. Where we are now is that the world has changed in this really important way, and we need to make sure our education system is dealing with that as well. So it's both the technology in the maths classroom, which I know lots of MA members will be especially interested in, but it's also how maths is contributing to the development of all these other fantastic tools in artificial intelligence and data science that are affecting the whole world now, and making sure our education system is equipping young people for that. And that's a difficult thing to get right because it's all brand new, but we're doing it. You're doing it and getting your hands dirty trying to make it happen. So I think, Tom, on that point, I think I might say thanks very much. We could talk for ages, couldn't we? We could talk for a lot more about the technology in maths classroom as well. But I think the big message that I want to get out from this is that, so I've got these themes around attitudes to maths and teacher supply and technology. They're really interlinked, those themes. The attitudes to maths thing, I think that young people, the world that they're growing up in, the world that they experience is, we need to make sure that they can perceive their education as being relevant to that world. And this work is obviously really important for that. And around teachers, we really need to make sure that we're equipping teachers to be empowered by the use of technology to enhance their teaching and their students' learning, and really try to there's an attitudinal thing there to change, isn't there, about that? And I think all of this work is all these things are all sort of muddled up together, but we're living in such a period of change, and it's great that we're doing what we can to try and think about how our education system can adapt to that. So thanks very much, Tom. Thanks very much for the work that you're doing. And
no, I've enjoyed it. Thank you.
Great. Okay. Thanks very much, Tom. Great to talk. Thank you.